Hello there. Now that we have seen how we can use while loop, and particularly when for is not applicable, in such situations only we need to use the while loop. So how to do that? In this video, let's see a particular sample of how and where we need to use while loop and how exactly to use it. The problem statement is very simple here. Accept a number and find out the reverse of that number. For example, if you have accepted say 7845, then the output that should be printed is 5487. We need to compute an exactly reverse number 5487, like that. Now if you have to perform this, first of all what you should do is you must open a notepad or do some exercise on paper. So if I have a number, let's say, what is that? 7845. How can I do the reverse of this number? So in order to do the reverse of this number, what I want very first is I want 5. I want 5 to be extracted very first, and then what I want to do is I need to multiply it by 1000. But multiply it by 1000 means I know that the length of the number is 4 digit. Whereas while doing this kind of code, you don't know the length. It may be a 3 digit number, it may be a 5 digit number, it may be a 6 digit number also. So taking 5 and multiply it by 1000 won't be a better situation or won't be a better solution for me. So instead, let's do this. 5 multiplied by 10, and then let's do addition of the next number into it. So 4. So that will give me 54. Then 54 multiplied by 10, and let's add 8 into it. That gives me 548. Similarly, let's do 548 multiplied by 10 and add 7 into it. That gives me 5487. Now we need to do exactly this. And in order to do this, what I want is I want to extract the last digit of the number, and then I want to completely remove that particular number from the given number so that next manipulation or next operation can be performed. Let's see how we can do it with Python. I'll take a new file here, and just like always, I'll save it to documents and pycodes and reverse of number. So a is equal to int input, enter a number, like before, print it. You have entered a, and now let's see how we can do it. As I said, I want to reduce this number and reduce this number as long as it becomes 0. So while a is greater than 0, I will perform some operation. What that operation should be? Let's see. Let's take a result variable, say rev. Let's call it 0. And here what I'll do is I'll take another variable which should store the remainder. Let's say rem is equal to a, not divide, but mod 10. Now what will happen when you mod it by 10? The result is 7840. So definitely the division result is 7840. So after mod, what you will get is 5. Here at this moment, what I got is 5. So what I'll do is I'll compute rev is equal to rev multiplied by 10. So 5, first time it's 0. Okay, first time it's 0. So 0 multiplied by 10 will result into 0 plus rem. Means the result or the rev will contain 5 at this moment. And then what I'll do is I will reduce the a by a divide by 10. So this will do a floor division. After floor division, what will happen? 7845 divided by 10 will give 7840. Or let's try it on Python shell. 7845 divided by 10. So it's 784 actually. Yeah, 784. The floor division. So what we remain is with 784, and next time the same operation will be continued, and again the reverse number is calculated with the remainder, and the whole execution will perform as long as a is greater than 0. As long as a becomes 0, your reverse number has been calculated. Your reverse number is REV. I hope this logic should work. Let's try it on. We'll use the same number 7845, and it worked like a charm. You can hand run it as many times as you want, how it reduces the number and how it performs the particular operation. It's pretty simple. It's nothing very fancy, or there is no rocket science into it. Let's try it with a smaller number. 798. Let's try it with a bigger number. 987456 654789. That's about it. So study this code well and then try to execute it on your own without looking into this video. That would clarify your logic pretty much well. Thanks for watching this video.